series series word come from Latin word zero, which means I join or add. So series become from zero. Now what is the definition? Let A and B a sequence, then the sum A1 plus A2 plus A3, this I write AN, is called series. Now we talk about the convergence of the series. Convergence of the series. So first I define partial sum. Partial sum Sn is called partial sum of the series, that is Sn is equal to A1 plus A2 plus so on up to An. That is the first term of the series is Sn. That means you can say S1 is A1, S2 the first two term A1 plus S2, S3 is A1 plus A2 plus A3. Like this, Sn is the first term. So the convergence of the series, or we say a series An is called convergent if the sequence of partial sum, that is the sequence of partial sum, what is that? S1, S2, S3 converges. Otherwise divergent. If this sequence is not convergent, then we say it is divergent. Otherwise divergent. Convergent means you understand that if this sequence has a finite this sequence converges to some finite number, we say it is convergent. So now you see one example, a simple example we can see. Show that the series Rn, where n 1 to infinity and R lies between, R is less than 1, I say this. Converges to 1 upon 1 minus r. So here Sn is equal to 1 plus r, okay, and I take from 0, n varies from 0 to infinity. Then Sn is 1 plus r square plus r cube and so on plus r n. Then what happens? If I multiply r to Sn, that means if left side I multiply, it is multiplied to the right side also. Then this become r plus r square plus r cube. Last term, second last is Rn, and Rn plus 1 is the last. Now, if I subtract, this you say 1, this you say 2. If I subtract 1 from 2, subtract 1 from 2, what I get? Rsn minus Sn, then these all become 1 minus. What happens? This r will cancel, this will cancel, and this will cancel. So we left with r n plus 1 minus 1. Now Sn I take common, so Sn r minus 1 is equal to r n plus 1 minus 1. Now Sn is equal to r n plus 1 minus 1 divided by r minus 1. Now if I take limit, what happens? Now limit n approach to infinity, Sn is equal to limit n approach to infinity, because this term and this lower term is free from that Rn plus 1 minus 1, and this is r minus 1. So this term and this denominator also free from n, so I can take them out. That means 1 by r minus 1 is out, and inside I take limit r n plus 1. This and this minus 1 is at is. Now what happened about this? Because r lies between 1 and 0. That means since r is less than 1, or you say this, so limit of Rn approach to 0, so this part becomes 0. Therefore we have this is equal to 1 upon 1 minus r into 0 minus 1, and this is 1 by 1 minus r. This is our answer. This is our answer.